Hello everyone, today's question is, in van der Waals equation, P plus A n square over V square, V minus NB is equal to nRT, the constant A reflects the actual volume of gas molecules. This is van der Waals gas equation or real gas equation. For this, the statement that constant A reflects the actual volume of the gas molecule is false. This van der Waals equation is for real gases. For real gases, it is assumed that molecular attraction is not negligible. Molecules attract each other so that gas can be liquefied or solidified. And secondly, molecular volume is not negligible as compared to total volume of the gas. So in this equation, two new constants are introduced with pressure, volume, temperature, moles and universal gas constant, and they are A and B. They are called van der Waals constant. The first constant A give indirect measure of intermolecular attraction. So, it is measurement of attractive interaction between molecules. Higher value of A gives large attraction between gas molecules. That gas is liquefied easily. Second constant B. This is excluded volume. In case of ideal gas, the molecular volume is neglected as compared to total volume of the gas because it is assumed that 99.99% space is empty and only 0.01% space is occupied by gas molecule. That can be neglected, but for real gases in their compressed state, this molecular volume cannot be neglected. So, according to this explanation, the statement given in the question is false. Thank you.
हमें बताना है कि जो हमें स्टेटमेंट गिवन है वो ट्रू है या फॉल्स। तो ये स्टेटमेंट कहता है कि जो काइनेटिक एनर्जी है एक मॉलिक्यूल की वो 0 होगी 0 डिग्री सेल्सियस पर। ठीक है, तो अकॉर्डिंग टू काइनेटिक मॉलिक्यूलर थ्योरी इन्होंने हमें कहा था कि जो हमारे पास एक गैस है जो उसकी एवरेज काइनेटिक एनर्जी होगी वो प्रोपोर्शनल होगी किसके, एब्सोल्यूट टेम्परेचर के, राइट। तो अब हमारे पास इस थ्योरी के अकॉर्डिंग जो टेम्परेचर है वो एब्सोल्यूट टेम्परेचर के प्रोपोर्शनल है काइनेटिक एनर्जी। अब यहाँ पर अगर हम देखें कि हमारे पास जो टेम्परेचर है वो था 0 डिग्री सेल्सियस जो हमें गिवन है, तो ये प्रोपोर्शनल होना चाहिए काइनेटिक एनर्जी के। अब ये तो 0 है तो इसका मतलब जो काइनेटिक एनर्जी है वो भी क्या होगी, 0 होगी। तो इसीलिए जो ये स्टेटमेंट है हमारे पास ये क्या है, ट्रू।
Hello students, we have one evacuated vessel which has movable piston under the external pressure of 1 atm. Okay, and this evacuated vessel have 0.1 mole of helium and 1 mole of unknown compound whose vapor pressure is 0.68 atm at 0 degree Celsius. Why they mention about the vapor pressure? Because that unknown compound have two components. It also has the liquid state and it also has the vapor phase. So we need to find out the total volume in liter of the gases at 0 degrees Celsius. Okay, so first of all, let me clear you that this 1 mole of unknown compound contains vapor phase mole plus liquid phase mole. Okay, so we can't apply directly PV is equal to nRT here. So what we do, we apply Dalton's law of partial pressure. Dalton's law of partial pressure, right? So what is Dalton's law of partial pressure? Dalton's law of partial pressure is a gas law which states that the total pressure exerted by a mixture of gases is equal to the sum of the partial pressure exerted by each individual gas in the mixture. For example, if we take P total and we have three gases A, B, C, then this P total is equal to the partial pressure of all three gases. In the another form, we can say that this partial pressure of A is equal to the mole fraction of this gas into total pressure, and Pb is equal to mole fraction of this P into total pressure, and similarly for partial pressure of C is equal to Xc into total pressure, where Xc, Xp and Xp are mole fractions of A, B and C, and mole fraction is the ratio of the moles of that component to the total moles. Okay. Now let us apply this partial pressure in our question. So what we have in our question, that 0.68 is the partial pressure. It is given here. So this is the partial pressure, and two gases are present in the vapor. The first one is helium and the other one is that unknown compound vapor. Okay, so this become NX. Suppose that that unknown compound is NX moles, and this become NX plus 0.1 because helium is of 0.1 mole. So after solving this, what we get? We get NX is equal to 0.212, right? So this is the value of NX. Now we can apply PV is equal to nRT, because PV is equal to nRT is for only gases and mainly for ideal gases, and we need to suppose the behavior as ideal gas. So now after putting pressure, so pressure is 1. Pressure is 1. Why? Because suppose we have a container here. This is piston. Okay, this is unknown compound in liquid state, and this is helium gas all over there, and this is vapor of that unknown compound. So if there is 1 atm of external pressure, then to fix this piston also there is 1 atm of pressure is applied from the below side. So the total pressure is how much? 1 atm of the gas also. So 1 into V is equal to, what are the moles? Moles is 0.212, that of unknown component, and for helium it is 0.1. So this is like this, and into universal gas constant, which is 0.821 into temperature. And what is the temperature? At 0 degrees Celsius. So this becomes 273 Kelvin, right? So from here, while calculating, we get V as 7 liter. So the volume of the gas is 7 liter. Thank you.